Okay, so are these vectors linearly dependent or not? So if they are, then, so for example, the ones in question A, we would have some real number m times a vector A plus another real number n times a vector B equal to C. Okay, so that's true for each m times each value in A plus n times each value in B equals the corresponding value in C. Okay, so let's write them out as simultaneous equations. So m times the first value is 2m, n times the first value in B is 3n, equals the first value in C is 5. Equation 2, 1m plus minus, not plus, so minus 1 times n equals 6. Let's do that quickly. 3 times, okay. So we're going to have 1 plus 3 times 2. Okay, so it just gets rid of the ends. So 2m plus 3 gives me 5m is equal to 5 plus 3 times 6 is 18, 23. And that makes m equal to 23 divided by 5. And to sub it back into 2, let's sub it back into 2. So 23 on 5 minus n equals 6. And that makes, so that's 30 on 5, take away 23, 7 on 5. So, and taking into account the negative, minus 7 on 5. And you could rewrite this as, so we've got 7 on 5, 23 on 5. So 23 on 5 times 2 and 1 minus 7 on 5 is equal to 5 and 6. All right, so that's basic. Oh, I forgot to write the actual vector for B. So that would be 3 and minus 1 equals 5 and 6. All right, great. So it's a little bit annoying though. It's taking up too much room. Give me 5 seconds. What's it doing? It's weird. So somewhere over here. All right, and I'll just put it as a different color so it doesn't matter, it's too close. All right, cool. Okay, let's have a look at B. So now we're going to have to look at 3 different values, okay? So we've got 3-dimensional vectors here. So if we're going to have m times A plus n times B is equal to C again, we'll need to do 3 equations. So 3m plus 2n is equal to minus 1. Equation 2, 4m plus n equals 0. And equation 3 is minus m plus 3n equals 1. Okay, and so if we to do the simultaneous equations with the first 2, which one should I take away? That will be bigger. Okay, so if I do 2 times 2 minus equation 1, so now we've got 8m and 2n equals 0. So 8 take away 3 is 5m. The n's disappear. And take away minus gives me that. So m is equal to 1 on 5, which means that if I sub them back into equation 2, looks easy, then 4 times 1 on 5 plus n equals 0. So n has to equal minus 4 on 5. And let's try that in equation 3. Equation 3, right, so there's only one possible solution for the first two. And if I use that on equation 3, what have we got? Minus 1 on 5 plus 3 times minus 4 on 5 is equal to minus 13 on 5, which is not equal to the 1. So A, B, and C are not linearly dependent. Oh, God. Oh. This thing's going to make me cry. What's dependent? It's got new batteries. Anyhow, all right, so the fact that these ones are, there's 3 two-dimensional ones, and I'll show you in class with some GeoGebra apps why that's just not interesting. Okay, that will always be the case unless there's some parallel vectors going on there. But to try and find 3 three-dimensional ones is interesting. Okay, so the way around that would be to think about if we had 4 three-dimensional ones, there will be some linear dependence there as well. All right, good luck, and I'll see you in the next exercise or example.